Single recessive epistasis is where homozygous recessive condition at one locus masks or modifies the expression of alleles at the second locus. So I've created a pathway. If you have a dominant allele, A allele, you will create an enzyme that will turn a white bunny into a black bunny. However, if that allele is double recessive, it will not produce the enzyme required to transform a white bunny into a black bunny. And the vice versa is the same for the B allele. The alleles can be thought of as a key and lock mechanism for the enzyme. For example, in enzyme A, you need a dominant allele key in order to turn it on and convert a white bunny into a black bunny. The same goes for enzyme B, where you need a dominant B allele key in order to turn on the machine and produce a purple bunny from a black bunny. However, if you insert the incorrect key, for example, the double recessive A key, it will not turn on the machine to produce the black bunny from the white bunny. And without the black bunny as the intermediate, you can't produce a purple bunny because enzyme B requires that you have a B dominant key with a black bunny. We're going to use my model to cross a dihybrid cross. That will result in a 9:3:3:1 ratio in genotype. However, the last two genotypes will produce the same phenotype because of the restriction on the first enzyme, resulting in white bunnies. So the ratio of phenotypes ends up being 9 purple to 3 black to 4 white. So for this cross, I made a branch diagram to show the ratio of the genotype. And on the right, I have written that 3 out of 8 will be big A blank, big B blank. 1/8 will be big A blank and double recessive Bs. And the third one would be 3/8 double recessive A, dominant B blank, and 1/8 double recessive A and double recessive B. In the previous slide, we showed that the ratio for the genotype will be 3:1 to 3:1. However, the phenotype will result in a ratio of 3 purple to 1 black to 4 white. That's because the last two genotype produces the same phenotype due to the restriction of having double recessive A's, resulting in no enzymes being produced at the enzyme A, resulting in white.